Okay guys, so here's the review for the mid-chapter check. It says find the greatest common factor of 18 and 14. Show your work. So the way you want to do this really, easiest way in my opinion, is let's find the factors. And what factors are just all the numbers that multiply into 18. Let's find the factors of 18. So for example, let's divide 18 by 2. 2 times 9 is 18. Okay, and I'm going to find all the prime factors of this. So 9 is 3 times 3. So what this is saying is that 2 times 3 times 3 is 18. And 14 is 2 times 7. Okay, so 2 times 7 is 14. Okay, so the factors that they actually have in common, are 2. So they both have a 2. Do they both have 3s? No, this one doesn't have a 3. And this one has a 7, but this one doesn't. So the factors that they have in common are 2. So my greatest common factor is 2. Okay, next one. Find the lowest common multiple, or sometimes it's called the least common multiple of 3, 9, and 15. Show your work. So the way I do something like this is if I want to find the least common multiple of 3, 9, and 15, I start off with my biggest number, like 15, and I write out all the multiples for 15. 30, 45, 60, 75, right? And it keeps going. You can next write out the multiples of 9. So 9, 18, 27, 36, 45, 54, 63, and that keeps going. And then write out the multiples for 3. 3, 6, 9, 12, 15, 18, 21, 24, 27, 30. Okay, now you need to find a number in here, a multiple that every single one of them has in common. So this is for 15. This is for 9. This is for 3. Okay, now I need to find a number that all of them have in common. So 15, does a 9 have a 15? No, so it definitely can't be a 15. 30, and I always start with the biggest one. 30, does 9 have 30? No. 27, 36, no, so it can't be 30. 45, does 9 have 45? Yes, it does. 45, 45. Does a 3 have 45? Maybe. Let me write out the rest and see how far we can get. 30, 33, 36, 39, 42. Look at this, 45. There it is. So all three, the 15, the 9, and the 3, have 45 as the smallest multiple. It's the smallest number that all of these numbers go into. Okay, so 45 is my least common multiple, or in this case they say lowest. All right, divide 35 cans of soda into a group, so the ratio is into 2 groups, so the ratio is 3/4. So here's the trick that I know with this one. Well, it says use a bar diagram. I'm going to show you a different way. I would recommend doing it this way. If there's 3 to 4, okay, you have to realize if there's 3 and 4, that's 7. Okay, so we're talking about a ratio of a total of 7. So I need to take this. I'm going to divide it by 7. So 35 divided by 7 is 5. So I'm going to take groups of 5 and I'm going to organize them into this ratio. So I have 3 groups of 5. Let me write that here like this. 3 groups of 5. That's for the 3. And then I have 4 groups of 5 for this one. That's for the 4. Okay? So my ratio is going to be 3 times 5 is 15. 4 times 5 is 20. That ratio has this ratio, but it's 35 cans. 15 plus 20 is 35, and then 15 to 20 is the same as 3/4. All right, next. Need to hurry up. Okay, Ahmed shot 24 baskets in 4 minutes. Khalid shot 25 baskets in 5 minutes. How many more baskets did Ahmed shoot per minute? Okay, so we need to set this up in per minute. So we have Ahmed, 24 per 4 minutes. Okay, and then Khalid, 25 shots per 5 minutes. All right, well, let's keep breaking these down some. Let's simplify this so we can get a unit rate. So if I want a unit rate, I want to divide by whatever the denominator is. So I'm going to divide by 4, divide by 4. So I have 6 shots per 1 minute. So every minute, Ahmed shoots 6 times. This one I'm going to convert to a unit rate by dividing by 5. So I'm going to have 5 shots. Khalid shot 5 shots every 1 minute. So how many more baskets did Ahmed shoot per minute? The difference between 6 and 5. So he shot 1 more basket per minute. Okay. Ahmed shot 1 more basket per minute. All right, next one. Ruba walked 3 blocks in 15 minutes. Based on this rate, determine if each statement is true. So 15 blocks in 3 minutes. Again, we want to convert this into a unit rate. That makes it the easiest. Okay, so to do that, I want to divide by whatever's in my denominator on the bottom. So I'm going to divide by 3. Divide by 3. 15 divided by 3 is 5 blocks over 1 minute. So Ruba walks 5 blocks in 1 minute. Now let's answer these questions. We're supposed to, based on this rate, determine if each statement is true or false. So then can Ruba walk 9 blocks in 45 minutes? Okay, so if she can walk 5 blocks in 1 minute, is it possible for her to walk 9 blocks in 45 minutes? Will she walk 9 blocks in 45 minutes? Well, let's see. 45 minutes, that means I'm going to take this, multiply by 45, multiply this by 45. I'm going to stop here. 1 times 45 is 45 minutes, but 5 times 45 is way more than 9 blocks. So that's definitely false, not true. Let's do this one. Ruba walks 4 blocks in 25 minutes. Did I write this? Whoops. My mistake. Let's do this again. Starting over. Let's try this one more time. I messed up on my rate here. So it's 3 blocks, 3 blocks in 15 minutes. Okay, or we can even switch that. Let's go ahead and do it that way. Let's say 15 minutes per 3 blocks. So how long does it take to walk 1 block? 15 divided by 3 is 5 minutes per 1 block. Okay, now let's answer these questions. So how long will it take to walk 9 blocks? Okay, so if it took her, this is getting messy, but I'm going to have to write up here. So if it took her 5 minutes to walk 1 block per 1 block, is that the same thing as 9 blocks in 45 minutes? That's the question. Is that the same as 45 minutes for 9 blocks? Well, let's find out. If it is, then whatever we multiplied by here will be the same as what we multiplied by here. So 1 block times 9 equals 9 blocks. 5 minutes times 9 equals 45. So because those are the same, that actually is true. Okay, let's try another one. What if Ruba walks 4 blocks in 25 minutes? Is that the same rate? Okay, well, we have this again. 5 over 1. Now I'm going to stop writing, so that's 5 blocks, or 5 minutes, 1 block. And then how does that compare? Or is it equal to, is it the same rate as 25 over 4? So here I multiply by 4. Here I multiply by 5. So because those are not the same, that's false. Let's do the next one. 8 blocks in 40 minutes. Okay, so is 5 minutes per 1 block the same as 40 minutes per 8 blocks? Let's see. 5 times what is 40? Times 8. 1 times what is 8? Times 8. Those are the same. So, yes, that's true. 12 blocks, 60 minutes. It's the same thing. So, here we go. I'm going to do the work right here. 12 in, 5 and 1. 5 and 1, is that the same as 60 and 12? Times 12, 5 times 12 is 60. Those are the same, so that's true. All right, next one. Simplify each fraction. So 16 divided by 80. So to simplify, you're just wanting to divide both of these numbers by the greatest common factor. So I'll show you another way of doing it also. This is even easier sometimes if you don't know what the greatest common factor is. For example, if I divide by 8, because I know 8 goes into 16 and 80, so 8 goes into 16 twice, 8 goes into 80 10 times. So I'm not quite done because, look, that can simplify even further. I can divide both 2 and 10 by another 2. 2 divided by 2 is 1, 10 divided by 2 is 5. That's the answer, 1 over 5. That's a simplified fraction. So let's do this one. 4 over 10. I can divide both 4 and 10 by 2. 4 divided by 2 is 2. 10 divided by 2 is 5. That is simplified. There's nothing else that can divide both 2 and 5. Okay, last one. 48 and 200. I'm going to start off with a simple one. I'm going to divide by, well, I guess I could divide by 4. You can divide by 2, just divide by whatever until you can't divide anymore. That's pretty much what you're doing. 48 divided by 4 is 12. 200 divided by 4 is, what, 50. So we can divide again. So there's 12 and 50. Let's divide this again by 2, which equals 12 divided by 2 is 6. 50 divided by 2 is 25. Now there are no numbers that go into 6 and 25. So that's the simplified fraction, 6 over 25. Okay, last one. The golden ratio is a rectangle. The golden rectangle is a rectangle in which the ratio of the length to the width is approximately 1.618 to 1. This ratio is called the golden ratio table. Make a ratio table to show the approximate lengths of golden rectangles given widths that are 1, 2, 3, and 4 units. Okay, so widths 1, 2, 3, and 4. If the width is 1, it says right here that the length should be about 1.618. So if the length or the width is 2, then it's going to be 2 of those, which, I mean, you can multiply it on your paper, but for the sake of time, I'm going to quickly use a calculator. Here we go. 1.618 times 2. 3.236, or 1.618 times 3. 4.854, or 1.618 times